So the main idea, the main way that we did this study was we imaged people in the scanner before and after 48 hours of sleep deprivation. And one of the primary tasks we used was the one that I just described. I'll say it again. People saw 1, 3, or 6 letters for a few seconds. They waited 7 seconds. A probe letter came up, and they had to decide whether that was one of the letters that had been presented to them. So we gave them the exact same task pre and post. And what we found behaviorally was that people were slower, and sometimes maybe 20% of the time they didn't respond within the time limit. And then we imaged them with fMRI while they were doing that, and we could look during the stimulus phase or the retention phase or the probe phase, when they saw the letters, while they were retaining the letters, or when we asked them, is that one that you saw, what was going on in their brain. The way that we approach looking at these data is a little different than other labs. So what we do is, first of all, we're interested in what changes from pre to post sleep deprivation. And we look at the brain as a whole rather than looking at one particular area of the brain. We try to find a set of brain areas that are working together. And we call that a network. It's not a network like a neurophysiologist would have, one neuron wired to another. But because it's a set of areas that work together, we call it a network. So we're looking for a brain network that reduced its activity from pre to post sleep deprivation. And the other thing we were interested in is, could we find a network where that happened in every single person? And the thing that we were hoping for is, if we found such a network, that the people who did worse after sleep deprivation would show more of a loss in the use of that network than the others. And that's what we identified. So we identified this brain network. So some of the areas that were, the areas that showed reduced activation were in the back of the head, some occipital areas and some parietal areas. Some of the areas that sort of maintained activation or sometimes increased with sleep deprivation, because it's sort of like a fulcrum, this network, were towards the front of the head. So we identified this network that the more it reduced its activation from pre to post sleep deprivation, those people who showed more of a reduction were the ones who did the worst. So in a sense, we solved the first problem. We found something in the brain that was going on in the brain that was associated with differential susceptibility to sleep deprivation. That was already quite in advance. No one had really had a handle on that. The truth is that it's very hard, if you just look at someone or talk to them, to predict whether they can handle sleep deprivation well or not, no matter what they tell you. Then what we try to do is say, okay, are we just seeing something on imaging, or is it something that really has to do with people's behavior? And that's where we use the transcranial magnetic stimulation. So the idea was that with TMS, depending on what you're doing is giving these pulses of magnetism, pretty intense. You can focus what area of the brain that you put it on. And depending on the frequency, you can either stimulate that area or inhibit function in that area. So we picked an area that showed reduction post-sleep deprivation, and we tried to stimulate it. And our hope was that if we stimulated that area, we could improve people's performance. And we focused on the occipital and the occipital and the parietal areas that seemed to show the most reduction. And what we found, which was surprising to me, is that, first of all, the stimulation to the occipital area did help people respond a little faster compared to some other area that had nothing to do with the network. And the people who benefited most from that stimulation were the people who had showed the most reduction in the network, which is another confirmation that we were finding something interesting. So I found that quite surprising. Now, it's not a cure for sleep deprivation. It was only while we were stimulating and while they were performing that task. So to imagine, let's say you could really bring that into real life, you'd have to imagine like a truck driver who's very sleepy having a magnetic stimulator on their head. So I don't think it's really very practical. But it was an idea of showing that we have this brain network. Maybe we could intervene in other ways. The kind of things that we thought about, if we were to continue that line of research, would be maybe we could train people using feedback to actually, using the kind of neurobiofeedback to actually use that network more effectively. So if they were feeling tired, maybe they could actually, by themselves, upregulate that network. Then the final experiment that we did was even more dramatic. What we did is we did the exact same thing. We sleep deprived people for 48 hours, but twice a day during the 2 days of sleep deprivation, they did this memory task that I described, and they got stimulation to that brain area while they were doing the memory task. And some people got that stimulation, and some were in like a placebo group. They didn't get it. And overall, we didn't see a huge difference between this TMS treat. It was like a drug study, really, but using TMS. We didn't see huge differences between the treated group and the untreated group, but on some very specific measures, we did see some differential improvement in the TMS group. And why that's interesting is that the post-testing wasn't done while they were getting TMS. So there was a more long-term relationship. So perhaps getting that 4 sessions of stimulation actually helped these people regulate this network a little better.